Let's go over what's called either water of hydration or water of crystallization problems. And this is because frequently problems like this are on the AP test, and actually this is kind of an entry point to stoichiometry. Hopefully you have done an experiment in which you have dehydrated a hydrated crystal. That is, you've driven the water off. And here's what the problems look like. You're given, or you find in the lab, a mass of a given amount of the hydrate. And then you dehydrate it. You use heat to drive off the water that's trapped in the crystal. And you find the mass of that salt once that water has been driven off. Then you find the moles of that salt from the formula. You can find the molar mass of the anhydrous salt and find the number of moles. You can find the number of moles of water that's been driven off from the mass that is lost. And we find that it's usually good to work in millimoles, so your masses and your mass change should be multiplied by 1,000 milligrams per gram to get that. Just to understand what water of hydration is, it's a salt with water molecules embedded in the crystalline structure of the salt. They're known as hydrates, and they obey the law of definite composition. That is, there is a whole number ratio between the crystalline substance, that could be calcium chloride, copper sulfate, all kinds of things, and the water. There's a given molar ratio of water to the salt that is a whole number. So let's do a problem. Calcium chloride is a hydrate. And if you heat 100 grams, all the water's gone and 50.1 grams of the anhydrous salt is left. So the questions are, what's the percent water in the hydrate, and what's the formula for the hydrate? Now the percentage of water is done just like you would do any percent problem. In this case, we've got 100 grams of the hydrate. We drive off the water and 50.1 grams will be left. That means 49.9 grams of water was trapped in that crystal. The percent water then is 49.9 grams, the water, divided by 100 grams, that was the hydrate, and of course to get a percent you have to multiply by 100. So 49.9% is the answer. Now the formula is solved this way. You first of all add up the mass of the atoms in the formula. You get what's called the formula mass or the molar mass. Calcium is 40. 2 chlorides are 71. That's 111 grams. Then we find the moles of the anhydrate calcium chloride. 50.1 grams of the calcium chloride is left. When you divide that by 111 grams per mole, you get 0.451 moles of anhydrous calcium chloride. To find the moles of water, of course, you divide the mass of water, 49.9, by 18, the molar mass of water, and that gives you 2.77 moles. The last thing you're going to do is find the ratio of moles of water to moles of anhydrate, and if you put that into your calculator, you see that this is almost exactly 6 times the moles of the anhydrous, and so we say 6 is the nearest whole number, and the formula for the hydrate is CaCl2.6H2O. This is what we call an association symbol that tells us the ratio of water to calcium chloride. Here's another practice problem, and I would encourage you to turn off the video now and solve it using the same method that we just did with the calcium chloride. We're back, and here's the problem. Magnesium sulfate hydrate has a mass of 13.52. We heat it, no water remains, and the remaining anhydrate is 6.60 grams. It's lost almost 7 grams. We want to find the formula and the name of the hydrate. Well, the formula of the anhydrate, since it's magnesium sulfate, must be MgSO4. The mass of water is the difference between the hydrate and the anhydrate, or 6.92 grams. Moles of water, 6.92 grams. We're going to multiply by the ratio 1 mole of water per 18 grams, and we get 0.384 moles of the water. The anhydrous magnesium sulfate is 6.60 grams, and we know that 1 mole of magnesium sulfate is 120 grams, so we divide by that, and we get 0.055 moles. Now we want to find the ratio of water to magnesium sulfate, and as you can see, it's 6.98, which is very, very close to 7. So here is the formula, MgSO4.7H2O, and we would call this magnesium sulfate heptahydrate. Now we're going to show you 6 more problems which you can write down and solve. They are not solved for you here. This is practice problem 2, practice problem 3, practice problem 4, practice problem 5, practice problem 6.